Happy Monday. It's the 25th of February, and we are going to learn about Dalton's Law today. So let me go ahead and zoom in on this guy. Going to turn off my Carly Rae and Owl City, and we're going to go ahead and title our notes. So this is going to be Dalton's Law of Partial Pressures. Go ahead and underline it. So before we actually go through and learn about Dalton's Law, we're actually, I'm actually going to insult your intelligence just a little bit, so bear with me. I'm going to draw a container. And then I'm going to draw some different colored marbles in this container. So I'm going to actually do shapes so that way you guys can do it. I'm going to draw 3 triangles. And then I'm going to draw 4 circles. 3, 4, and then I'm going to go ahead and draw 2 squares. So 1 square and 2 squares. So now for the insulting your intelligence part. Let's count up the total number of marbles. We're pretending that these are shaped marbles. So the total number of marbles is going to equal the triangles plus the number of circles plus the number of squares. Right? Because triangles, circles, and squares are what is in the jar. So let's see. I've got 3 triangles. I've got 4 circles. And I have 2 squares. So my total number of marbles is going to equal 9 total marbles. Right? That's from elementary school. I think we all know how to do that. So basically, Dalton's Law of Partial Pressures is this exact same concept, but instead of marbles, we're just going to be counting pressure, like atmospheres and millimeters mercury and torr. So Dalton's Law of Partial Pressure states, in a mixture of gases, the total pressure is the sum of the partial pressures of the gases. Now I'm going to go back up here. Now, these guys here, those were your parts, or partials. You can say partial. Okay, so these are all the parts, and they make up the total, or the whole. So next up, we're going to write Dalton's Law, the formula, PT equals pressure 1 plus pressure 2 plus pressure 3 plus pressure 4, etc., etc., etc. I'm going to box this guy up. Now, PT, that just stands for pressure total. And then these guys in here, those are my pressures of the individual gases. So just like the marbles, my total marbles equals all the marbles combined. My total pressure is just going to be all of the individual pressures. Simple math. So example 1, find the total pressure of the container if the pressure of NO2 is 7.4 atm, comma, the pressure of O2 is 8.5 atm, and the pressure of CO2 is 799 torr. Once again, I'm going to draw a little diagram so that way your brains can visually kind of figure out what's going on. Okay, so they told me I've got NO2, nitrogen dioxide, and his pressure is 7.4 atmospheres. They've also told me I've got oxygen in this container, and oxygen's pressure is 8.5 atmospheres. Last but least, they tell me I've got carbon dioxide, and carbon dioxide's pressure is 799 torr. So basically, all I need to do to find the total pressure is add these three up. So my pressure total is going to be the pressure of NO2 plus the pressure of O2 plus the pressure of CO2. So I'm going to go ahead and fill that in. The pressure of NO2 is 7.4 atm. The pressure of O2 is 8.5 atm. And the pressure of CO2 is 799 torr. Now here is the just one trick about these problems: units. They have to be in the same unit. So I'm going to make a little note. Must be in same unit. So I'm going to go ahead and convert the torr into atm. So 795 torr. I want to get rid of torr, so 760 torr for every 1 atm. With correct, this is what your calculator spits out. With correct sig figs, 3 sig figs, it becomes 105 atm. So instead of 799, I'm just going to say it's 1.05 atmospheres. Just kind of do a little cross that out. And I add those all up, and my calculator spits out 16.9, I believe 5. 16.95. Now I need to do sig figs. This is addition and subtraction. The rules for addition and subtraction are decimal places. So you look at the decimal places. This guy has 1, this guy has 1, this guy has 2. The lower number of decimal places is 1, so my answer has 1 decimal place. So the 5 bumps the 9 up, which bumps that guy up. So my final answer is pressure total equals 17.0 atm. Don't worry too much about the sig figs right now. Just get the idea that the total pressure is all of the pressures added up. Very simple concept. We're going to do one more example. So, example 2. Find the pressure of F2 if the pressure of O2 is 7.6 atm and the pressure of CH4 is 5.6 atm, period. The total pressure is 25.0 atm. So I'm going to go ahead and once again just draw just a little diagram so we can see more visually what's happening. So they want the pressure of F2. We don't know what that is, but we know the pressure of O2 is 7.6 atm, and we know the pressure of CH4 is 5.6 atm. And we know the total pressure is 25.0 atm. So we know that 7.6 plus 5.6 plus fluorine's pressure should give us 25 on the dot. So I'm going to write a little formula. Pressure total is going to equal the pressure of F2 plus the pressure of O2 plus the pressure of CH4. Now I'm going to do a little bit of plugging and chugging. Pressure is 25.0 atm for the total pressure. I want to find the pressure of F2. I know the pressure of O2 is 7.6 atm. And I know the pressure of CH4 is 5.6 atm. All my units are the same, so I'm good to go. So all I need to do is subtract 7.6 and 5.6 to solve for pressure of F2. Now my calculator spits out 11.8, and I need to look at sig figs. For addition and subtraction, you look at decimal places. 1 decimal place, 1 decimal place, 1 decimal place. Answer has 1 decimal place, so we're good to go. So the pressure of F2 equals 11.8 atm. So I hope you have enjoyed the lesson for today, and hopefully you'll have a nice evening, and I will see you tomorrow. Garvin out!